mathematicians. So far, you've learned two strategies you can use to solve quadratic equations. Awesome. Now, unfortunately, both of these strategies can only be used to solve special types of quadratic equations. Okay, here are the two special types. First case is when the variable is only being squared. Notice x is not to the first power, x is only being squared. Or it's in a binomial. It's only in a binomial being squared. If this happens, then we can use the square root method, which is essentially isolating the variable or binomial being squared using inverse operations, and then taking the square root of both sides to undo the squaring. Easy. We love it when we can do that. Now, the other special case we have is that when one side of the equation is 0 and the quadratic can be factored, then we factor the quadratic and use that special ZPP, zero product property, to find the values that will make either factor equal to 0. Great. So what in the world will we do if we have a quadratic that doesn't fit either of these cases, that doesn't just have the variable being squared, that can't be factored? Are we stuck? Of course not. Enter the quadratic formula. A very creative mathematician many years ago realized that if you have a quadratic equation, something that fits ax squared plus bx plus c equal to 0, that you can solve it. You can find the values for the variable that make this true by using a formula. And here's the formula that they came up with. The value or values for x are equal to the opposite of your b value divided by 2a plus or minus the square root of b squared minus 4ac, also divided by 2a. This is one version of the quadratic formula. Some people like this because hopefully your brain is lighting up because you notice the opposite of b over 2a, this is an axis of symmetry if you're thinking about a parabola. And then it's telling us that the two values for this equation are the axis of symmetry plus or minus that value. So you see those x values are symmetrical. So super cool. Now, probably the more common way you're going to see this is that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a, written as a single fraction. So you'll probably see this one more often. I like this one because it really tells us about symmetry, mathematician's choice. Now, I hope at this point you're feeling super skeptical. You're like, what? Is this magic? But it's not magic. The creative mathematician, what they did is they started with this generic quadratic, and then they used a technique called completing the square to derive and come up with this quadratic formula. Now, you'll also be learning how to complete the square in the next lesson, and you'll also be able to derive this later for yourself so that you can see that it truly is not magic. Let's try an example just to see the quadratic formula in action. Watch out though. You can only use the quadratic formula if one side of your equation is set equal to 0. So that's always a first step to take. All right, so here we have a quadratic equation. For this, we know a is equal to 2, b is equal to 8, and c is equal to 3. Great, we can just decode that. All right, what's our quadratic formula? How much of it do you remember? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so actually using the quadratic formula is just a matter of substituting your values for the variable and doing a little bit of arithmetic. So let's substitute negative 8 plus or minus 8 squared minus 4 times 2 times 3 all over 2 times 2. All right, let's do our arithmetic. Negative 8 plus or minus the square root of 64 minus 24 all over 4, and x is equal to negative 8 plus or minus the square root of 40 over 4. Now, to be honest, right at this point, we have our two solutions. What we're going to do for the remaining of this is just simplifying. All right, so the first thing I want to handle is I want to simplify my radical. I see it has a perfect square factor of 4, So plus or minus 2 times the square root of 10 over 4. At this point, I'm going to distribute division. So I have negative 8 divided by 4 plus or minus 2 square root 10 divided by 4, and x is equal to negative 2 plus or minus the square root of 10 over 2. One of the reasons I like to write the solution like this is it gives me a good visual. If I have a number line, here's 0. I'm going to start at negative 2. And let's see, square root of 10 over 2. Square root of 10 is a little bit more than 3 divided by 2. So it's like plus or minus about 3 halves. So plus 3 halves would bring me to the first solution, minus about 3 halves would give me to the second solution. All right, we're going to end with 2 practice problems. Pause me, solve both using the quadratic formula, and then come back to check your answers. Here are the solutions to the 2 equations. If you have any additional questions, please come and ask me in class.